This is the second video for Accelerated Geometry on Section 5.3, Parabolas. Today we're going to be looking at horizontal parabolas, so that would be parabolas that open to the left and to the right. But before we get started on those, I want to do a review for a vertical parabola, which we looked at in the video yesterday. So, for example, here we have the standard equation of our parabola is y minus 6 equals 1 over 8 times x minus 3 quantity squared. So, I want you to pause the video for a minute just to test yourself and see if you can fill out all of this information and draw the graph of the parabola. Okay, so check yourself. Your vertex should be at +3, +6, right here. Your p-value, when you set your 1/8 equal to the formula 1 over 4p, p comes out to be 2. So that means that from the vertex, you will count up 2 in the y direction to get to your focus. So jumping down here, that makes our focus 3, 8. Conversely, we go down 2 from our vertex to get to our directrix line, y equals 4. And then finally, because the vertex is at 3, 6, and the axis of symmetry has to be perpendicular to the directrix, the equation for the axis of symmetry is x equals 3. All right, so hopefully you got all of those pieces correct, because now we're going to take those graphs and we're basically just going to rotate them 90 degrees to create horizontal parabolas. And you'll remember that this third column over here, this was what we talked about yesterday with the vertical parabolas. And this column was actually covered up by a big blue rectangle yesterday. Well, now we're actually going to look at it. This is a horizontal parabola. So the standard equation for a horizontal parabola, if the vertex is the origin, is x equals 1 over 4p times y squared. Look at the one for the vertical. The only difference is that the x and the y have swapped spots. So if the parabola opens in the x direction, to the left or to the right, the variable that's squared should be the y variable. That's kind of not like we're used to seeing. And similar to opening up and down, your parabola is going to open to the right if p is greater than 0. So that would be a parabola like down here. This p-value would be greater than 0. And it's going to open to the left if p is less than 0. Your focus will be p0, and your directrix line will be x equals negative p. So that would be if your vertex is at the origin. Now let's go ahead and talk about what if we move our vertex away from the origin. Well, just like on the vertical ones, when we move away from the origin, the vertex coordinates are h, k. H is always attached to the x, k is always attached to the y. The same thing happens over here with the horizontal. But look, the h stays attached to the x, and the k stays attached to the y. Okay? Same thing, if p is greater than 0, it opens to the right. If p is less than 0, it opens to the left. These are your formulas for the focus and the directrix. Notice that the directrix line, both at the origin and not at the origin, your directrix line is vertical now. So it's going to be an x equals equation, which means that your axis of symmetry, this green line, is going to be a y equals equation. Okay? So there's all of your information for the horizontal parabolas. Let's actually put it to use now. What if I gave you some information about the parabola and asked you to write the equation for it? So here we want to write the equation of a parabola that has a focus of 6, 2, so that's my focus point, and a directrix line of x equals 4. So this right here is my directrix line. Okay, so you have to draw on what you remember from the video yesterday. Remember that the vertex has to be exactly in between, equidistant from your focus and your directrix. So the nice thing about having the graph here is that we can visually see that this point right here needs to be our vertex point. So the coordinates for that vertex point would be 5, 2. We can also now count really easily our p-value. Since we're going to the right, our p-value is a +1. And because of the placement of the directrix line and the focus, we know that this parabola has to open to the right, because when we draw it, it needs to have the focus inside of the parabola and it cannot cross the directrix line. So it has to open to the right like that, which tells me that I have to use my x minus h formula rather than my y minus k formula. It needs to start with an x because it's opening in the x direction. So I'm just going to go and fill in my numeric values. H is the x coordinate for my vertex, so that's 5. P is 1, so 4 times 1 would give me 4. And then K is the y coordinate for my vertex, which is 2. There's your equation. Okay, this is not any different from yesterday, except our variables have flip-flopped. So let's try one more. What if our vertex here says write the equation in standard form for the parabola with the vertex at 0, 0, and a directrix line of x equals negative 6. So we know when we see x equals that it's a vertical line. So that must mean if this is the vertex point, which way should my parabola be opening? It needs to open away from the directrix. So it must be opening this direction. And how far is it from the vertex to the directrix? That is negative 6 units. So that tells me that P must be positive 6, because remember P goes from the vertex to the focus. So my focus point would actually be right there at 6, 0. And they already gave me my vertex of 0, 0. So since it's 0, 0, I know that I'm going to use the basic equation of x equals 1 over 4p times y squared. So all I needed to know was that my p-value was 6. So the equation for that parabola is x equals 1 over 24 times y squared. All right, let's look at one more. It says write the standard equation for the parabola with the given graph. So this time they've given us a graph and they want us to come up with the equation. And remember, to write the equation for a parabola, we really need to know 3 things. What direction is it opening, which in this case is to the left, so that's the x direction. So that tells me which kind of standard equation to use. I'm going to use the x one. The second thing you need to know is where the vertex is. And the third thing you need to know is your p-value. Well, my vertex, notice how your axes are being counted. They're being counted by 2's. So my vertex is at 2, negative 5. And then for my p-value, I don't have a focus point that I can count to, but I can count backwards to my directrix line. So that's 2, 4. So since that's positive 4, p would have to be negative 4 units to get to my focus. The hard part's done. Now it's filling in your numeric values. So h is 2, p is negative 4, and k is negative 5. So cleaning that up a little bit, we get x minus 2 equals 1 over negative 16 times y plus 5 quantity squared. Okay, so here comes the ultimate test. Given an equation, find everything about that parabola and draw the graph. So here's my equation. X minus 1 equals 1/12 times y minus 3 quantity squared. First thing I want to identify is which way does it open. Well, I see that the x variable comes first, so that tells me that it either opens to the left or to the right. The next thing I notice is that my fraction is positive, so it's going to open in the positive x direction, which would be to the right. Then my vertex, remember we take opposite signs, the value attached to the x would be a positive 1, and the value attached to the y is positive 3. So I'm going to go immediately to my graph and put a point at 1, 3. That's my vertex. Then for my p-value, remember you can take your fraction, set it equal to 1 over 4p, cross multiply, and so p equals 3. So my p-value is 3. So now I'm going to go back to my graph, and from my vertex, I'm going to go 3 units in the x direction. So 1, 2, 3. That's my focus point. I'm going to go ahead and go down here and write the coordinates for that point, 4, 3. Then for my directrix line, I'm going to go back to my vertex, and I'm going to go -3 in the x direction and draw that line. And so that equation, since it's vertical, remember it's x equals, and what does x equal? Well, it goes through -2 on the x-axis, so x equals -2. Finally, I need to go back and sketch in my axis of symmetry, which I really could have done that as soon as I knew my vertex, but it doesn't matter the order that you do it in. That line being horizontal, that means the axis of symmetry is a y equals equation now. And what does y equal? Well, this goes through +3, so it's y equals +3. So I have all my information written down. I have all my stuff plotted on my graph. The only thing I need to remember is to make sure to go and draw something that looks like a parabola and that goes through the vertex point, opening in the correct direction. So something that opens to the right through that vertex point at 1, 3. Okay, so I want you to pause the video again, and I want you to give this one a try. Try to graph as much as you can of this parabola and to list the information. Okay, so let's see how you did. The first thing I noticed is that I had my x variable first, and it was not what was being squared, so I had to either open to the left or to the right. Then I went and checked my fraction. My fraction's negative, so that means that I was opening to the left. Then I found my vertex point. I took the opposite of the x and the opposite of the y, so my vertex is down here at 2, -1. So the third thing I did, so I took my fraction of -1/2 and I set it equal to my formula of 1/4p. That gave me a p-value of -1/2. So how many of you got that and thought that you had done it wrong because you got a fraction? Well, surprise, you had done it correctly. So since it's a -1/2, from my vertex, I went -1/2 of a unit in the x direction. That's my focus point. And the coordinates for that point are 1.5, -1. Then I went back to my vertex and I went +0.5 to draw my directrix line. That line is x equals, since it's vertical, and if you look at the value it goes through, x equals 2.5. Then I went back and did my axis of symmetry, which has to run perpendicular to my directrix and go through the vertex. That line, since it's horizontal, would be y equals, and in this case, -1. All right, I hope the horizontal parabolas are making sense to you. Tomorrow in class, we're going to be looking at all the parabolas put together, horizontal and vertical.